Proof of parallelogram properties. We know that parallelogram is a quadrilateral with both pair of opposite sides parallel to one another. Based on this, we can derive few properties of parallelogram. Those are opposite sides are equal, opposite angles are equal, adjacent angles are supplementary, diagonals bisect each other. We'll see how to prove each and every property of a parallelogram. Consider any parallelogram ABCD. In this, we can take any diagonal AC and BD or the two diagonals that we can draw in this parallelogram. Now let us consider BD, and this diagonal divides angle B into two parts, one angle 2. So angle B can be written as angle 1 plus angle 2. Similarly, angle D gets divided into two parts. So angle D is equal to angle 3 plus angle 4. Now if we look into this particular figure, consider any two parallel sides AB and CD. For that, if we ignore the other two sides, and the figure will look like this, wherein BD is like a transversal. As per the properties of parallel lines, we know that alternate interior angles are equal. This BD is making angle 1 with AB line and angle 4 with CD line. And these two are on either side of transversal BD. So they are alternate interior angles. And the statement of the parallel lines is these angles have to be equal. Considering that, we will write angle 1 is equal to angle 4. Now again, if we consider other two parallel lines, that is AD and BC, again BD is like a transversal to these lines, and angle 3 is made with the AD line, angle 2 is with BC line. So again they are on either side of transversal. Even these two alternate interior angles will be equal. So angle 2 equal to angle 3. Now consider the first statement that angle B is equal to 1 plus 2. In this, in place of 1, we can write angle 4 as angle 1 equal to angle 4, and in place of angle 2, we can write angle 3 as we have both the angles 2 and 3 equal. Now substituting the value, angle 3 plus angle 4 is nothing but angle D. These angles are opposite angles in the parallelogram. B and D are the opposite angles. When we take the diagonal BD, we can prove that angle B equal to angle D. In a similar way, if we take diagonal AC, we can prove angle A equal to angle C. So hence we can tell the opposite angles are equal. Now the next property is opposite sides are equal. For that, again considering the same diagonal, which gives that angle 1 equal to 4 and 2 equal to 3. Now consider the triangles ABD and BCD. In these, we will just write down 1 equal to 4 for the angles. BD side is same for both the triangles. And now angle 2 equal to angle 3. This is like angle, side, angle, that is ASA congruency. With that, we can tell both the triangles are congruent, and hence we can write the side opposite to angle 1 is AD and side opposite to angle 4 is BC. So AD equal to BC. Similarly, for angle 3, the side opposite is AB, and for angle 2, the side opposite to it is CD. So AB equal to CD. This shows that opposite sides are equal. Coming to the next property. Considering the same BD transversal and angle 1 equal to angle 4, now let us take the next diagonal, that is AC. Even AC, when we use this diagonal, angle A gets divided into two parts 5 and 6, and C gets divided into two parts 7 and 8. For AC, considering the same parallel lines AB and CD, angle 5 and angle 8 form the alternate interior angles. So these angles, they have to be equal to one another. So angle 5 equal to angle 8 considering AC diagonal. Now we will take the two triangles AOB and COD. In these two triangles, first thing is angle 1 and angle 4 are equal, and then we have angle 5 equal to angle 8. Along with that, angle AOB equal to angle COD, as they are vertically opposite angles. Now these are the three angles from both the triangles are equal, which means both the triangles are congruent using AAA congruency. Now when we apply the congruency to the sides, side opposite to angle 1 is AO, and to that of B, the side is CO. AO equal to CO, which means the AC diagonal got bisected at the point O. Now for angle 5 equal to angle 8, side opposite to 5 is BO, opposite to 8 it is DO. So BO equal to DO, which means the diagonal BD got bisected at point O. Hence we can tell that the diagonals bisect each other in a parallelogram. The fourth property is all adjacent angles or supplementary. For that, consider the parallelogram. In this, consider any two parallel sides. Let us take AD and BC. For that, CD is a transversal, and angle C and angle D are on the same side of this transversal, and they lie within the parallel lines. So they are co-interior angles or consecutive angles. As per the properties of parallel lines, consecutive angles are supplementary. So we can write that angle C plus angle D equal to 180 degrees. Now for the same parallel lines AD and BC, if we consider AB as a transversal, then we have B and A angles on the same side of transversal. So even these two form the consecutive angles, and hence they will add up to 180 degrees. In a similar way, if we consider AB and CD as parallel lines and AD as a transversal, A and D angles are on the same side of AD, so they form a consecutive pair adding up to 180 degrees. In a similar way, for AB and CD parallel lines, BC is also like a transversal, and B and C are on the same side of the transversal. So even these two angles add up to 180 degrees. Hence, we can tell that adjacent angles in a parallelogram are supplementary.